when an electrolyte is given, yes, it may be in form of a solution, but if concentrated, the ions of that concentrated ionic solid will be discharged in preference of the others. We don't follow the reactivity series in this case.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
In the previous videos, we introduced the topic well. We gave the key terms. We talked of the decomposition or ionization of different electrolytes. We've talked of the discharge of electrolyte, of the formed ions. We are now back to look at the factors that affect the choice of ions to be discharged at given electrodes. Before going to that, let us again look at briefly at the discharge. And remember what the word discharge means. Let us assume we have an aqueous solution of electrolyte Fb in aqueous state. It means that this electrolyte, being aqueous, it also has water in it. So the water will partially ionize to give hydrogen ions and the hydroxide ions. And then this electrolyte Fb will also ionize to give, let's say, a cation and an ion of B. To go on, it means that the cations we have in this electrolyte, we have hydrogen and A. And the anion we have in this electrolyte, we have the hydroxide from the water and B. This means that these two, the cations, will migrate to the cathode or to the negatively charged electrode, and the negatively charged ions will go to the positively charged electrode, which is the what? The anode. It means that one of these two cations, once at the cathode, one of them will be discharged, not both. And being positively charged ions, they will be discharged by gaining of electrons to form respective atom or molecule of the respective element. And then at the anode, the negatively charged ions will be discharged by loss of electron. This is also known as reduction. This is also known as oxidation. We are saying that one of these ones, not both. So in this video, we are going to look at the factors that determine the choice of an ion to be discharged at any electrode. These factors, one of these factors, we have the position of the element or radical in the reactivity series. It is one of the factors. And this factor states that the element or radical that is less reactive, or the one that is below the other, is easily discharged than the one that is more reactive or above. To note it, we say that the less reactive radical or element is easily discharged. And we remember that in the reactivity series, the one that is less reactive is the one that is below the other. We know the reactivity series. Let's start with that of elements. We know potassium as the most reactive. Sodium. We remember the reactivity series in the previous videos. Potassium, sodium. Sometimes they bring lithium here. I think we are flowing. Calcium comes. Magnesium comes. Aluminium comes. Carbon. Zinc. Iron. Lead. Hydrogen. Copper. Remember, there are many. Silver. No, mercury first, and then silver. We may not talk about the others. These are the common ones. Remember, this is the order of reactivity for elements, meaning that the potassium is more reactive than sodium so that if an electrolyte has two of these ones, potassium and sodium, basing on this factor, sodium will easily be discharged in preference of potassium, reason being that sodium is less reactive compared to potassium. If, for example, the electrolyte was copper 2 sulfate solution, if the electrolyte is copper 2 sulfate solution, it means, being a solution, the cations in it, we have hydrogen from water, and then the copper from this ionic salt, the copper 2 sulfate. It means we have two of them. We have copper and hydrogen. They have migrated to the cathode. We want to know which of them will be discharged. And remember, we said the discharge of these cations is gain of electrons. When we look at the reactivity series, hydrogen is above copper in the reactivity series. So this means the copper will be discharged in preference of hydrogen, implying that in the discharge we shall have copper 2 ions being discharged, and we said this discharge involves gain of electrons to form copper, solid copper. If an electrolyte comprises of two, let's say lead and silver, silver will be discharged in preference of lead because silver is less reactive compared to lead. So the silver ions will be discharged, and we said the discharge of positively charged ions is gain of electrons to form its respective atom or molecule. So we shall discharge the silver ions in preference of hydrogen or of lead ions because silver is less reactive. Let us assume an electrolyte comprises of magnesium and hydrogen. So we have magnesium ions, and let's assume the electrolyte was magnesium chloride. So this means the cations we have, this is magnesium chloride solution. So we have hydrogen from water and the magnesium ions from the magnesium chloride. It means that the hydrogen will be discharged in preference of the magnesium ions. Why? Because hydrogen is less reactive compared to this magnesium, meaning that it is easily discharged to form a molecule of hydrogen, which is hydrogen gas. Reason being, the hydrogen is less reactive compared to magnesium, so it is easily discharged. And remember, the discharge of these positively charged ions is by a gain of electrons. And then for the anions, this is for the cations, this reactivity series, I think we now know it very well. For the anions, fluorine is always the most reactive. Sulfate coming next. A nitrate comes next. Chlorine coming next. Bromine coming in that position. Iodine, and then the hydroxide being the least reactive. So this is the reactivity series for anions. You can think of, for me, those days when I was in school, I had my casson. I used to use to get the things in the head. Sonalgo, called Bena in the office. This could help me understand this well. Fluorine is not common. The most common are these ones. So I could use that. Sonalgo called Bena in office. Bena standing for bromine, in for iodine ion, office for hydroxide ion, and then the nalgo standing for a nitrate ion. So I could use this to remember it very well. Just to help me remember. Even this one I used to say, Kapelesav's candy meat as Zaitun invites Lady Hadija consume. Majorly these ones I asked. So meaning that if we have an electrolyte with hydroxide ions and sulfate ions, the hydroxide ions will easily be discharged compared in prevalence of the sulfate ions. Why? The hydroxide ions are less reactive, meaning that they are easily discharged. And we should not forget that, for example, for the discharge, we should know these equations. In the syllabus book, it is well stated in the learning outcomes that a learner should be good at writing these equations. So this is the hydroxide ion is discharged by formation of oxygen gas and water after losing 4 electrons. So the hydroxide ion loses 4 electrons to form oxygen gas that will be seen as bubbles, where at the anode, that will be, if the hydroxide ions being discharged, we shall be seeing bubbles of oxygen gas. As a result of the hydroxide ions there, are losing electrons to form oxygen gas that is seen as bubbles. Let us assume an electrolyte of, let's say, magnesium chloride solution. Being a solution, it means that it has magnesium ions and hydrogen ions from water. So the anions here, we shall have the chloride ions from the magnesium chloride and the hydroxide ions from the water, because it is an aqueous solution, meaning that it was formed by dissolving it in water. So when we go into the reactive series of anions, we are seeing that the hydroxide is less reactive compared to the chloride ions, meaning that the hydroxide ions will easily be discharged in preference to the chloride ions, because the hydroxide ions are less reactive. So they are easily discharged in preference of the chloride ions. So we should know the equations for the discharge. We are coming to this point. This is where we are coming to the point of knowing when this one is discharged, what will we form. So this means that on the anode, at the anode, the hydroxide ions will be discharged in preference to the chloride ion. Reason being that the hydroxide ions are less reactive compared to the chloride ions. Why? Because they will easily be discharged in preference of these ones that are more reactive. The second factor is concentration of the ions in the electrolyte. Members, when an electrolyte is given, yes, it may be in form of a solution, but if concentrated, the ions of that concentrated ionic solid will be discharged in preference of the others. We don't follow the reactivity series in this case. Let us assume the reaction, let us assume the electrolyte here is concentrated, let's say, magnesium chloride solution. This is now the electrolyte. So this means that in that electrolyte, being a solution, we have water in it, yes, but it remains a magnesium chloride solid. Yes, we shall have the hydrogen ions from the decomposition of water and the hydroxide ions from the decomposition of water. We shall have the magnesium ions from the decomposition of the magnesium chloride and the chloride ions from the decomposition of the magnesium chloride. If we are basing on the reactivity series, we could discharge hydrogen ions at the anode and at the cathode, because hydrogen is less reactive. But being the electrolyte being concentrated, we shall now not follow the reactivity series. We are now going to follow the amount of the electrolyte in the solution. So it means that in the electrolyte, we have more of the magnesium ions than the hydrogen ions. because of the concentration of them. So we shall discharge magnesium ions instead because they are more concentrated in the electrolyte than the hydrogen ions. So even for the electrolytes, for the anions, we shall discharge the chloride ions in preference of the hydroxide ions, irrespective of their reactivities, but because of their concentration in the electrolyte. So for concentrated electrolytes, we shall be discharging the ions from the respective ionic solute in it, not in the water. Why? Because of the concentrations of those ions. So the second factor is concentration of the ions. I think I'm flowing. For that, we shall not follow the reactivity series. We shall follow the concentration of the ions, where the highly concentrated ions will be discharged in preference of the other. Let us take another example of, let's say, if the electrolyte is concentrated sodium chloride solution. Yes, it is sodium chloride solution. It is a solution, meaning that it was made by dissolving this sodium chloride in water. So in the electrolyte, we have water and the sodium chloride. So the cations we shall have the hydrogen ions and the sodium ions. The anions we shall have the hydroxide ions from water and the chloride ions from the sodium chloride. It will remain that at the cathode, the sodium will be discharged in preference of the hydrogen. Why? Because in this electrolyte, the sodium ions are more concentrated than hydrogen ions. So they will easily be discharged because of their concentration. This time we are not basing on the reactivity. And then here, at the anode, the chloride ions will be discharged in preference of the hydroxide ions, just because the chloride ions are more concentrated in the electrolyte than the hydroxide ions. So the factor here we are basing on is concentration of the ions in the electrolyte. And the third factor is nature of the electrode. This kind of a factor is determined by the two natures of electrodes usually used. If an inert electrode is used, for example, the carbon electrodes, the graphite electrodes, the ions that will be discharged will only be those ions in the electrolyte. Because this electrode used is inert, it is not reactive. So it cannot be involved in the discharge process. It will not be decomposed even when an electric current passes through it. So the only ions that will be discharged will be the ions in the electrolyte. Why? Because the electrode used is inert. But there are cases where they will use active electrodes. We are going to look at it. For example, in the electrolysis of copper 2 sulfate, when they use inert electrodes, the graphite electrodes, The ions that will be discharged will only be the ions in the copper 2 sulfate solution. And for this we shall follow the reactivity series. But if they use an active electrode, if they use, let's say, copper at the anode and let's say impure copper at the cathode, they are using the copper electrodes. This is an active electrode. Even this one is copper. The copper itself, yes, it is an electrode. It will involve in the electrolysis. This copper will decompose to set ions in the solutions that will migrate. So I think that the nature of electrodes will also matter, whether active or inert, and they will greatly determine the fact, they will greatly determine the choice of ions to be discharged. And lastly, the fourth factor is the voltage of current introduced or applied in the electrolytic cell. The PD across an electrolytic cell, or the amount of current flowing through the electrolytic cell, may cause forced discharge of ions. Brings about forced discharge of ions. High voltage supply to any electrolytic cells will cause forced discharge of some ions. It may bring about discharge of chloride ions together with the hydroxide ions. So the voltage or the amount of current introduced to the cell will also determine which ions will be discharged. And in most cases, it will bring about a forced discharge of ions. And when we come back, we are going to look at electrolysis of different electrolytes, applying all the concepts we've gone through, talking about the decomposition, the flow of the ions, and the discharge processes in different electrolytic cells using different electrolytes. Don't forget to subscribe. The advantage of these lessons, you can pause and you note what you want. You can forward to check what you want, or rewind to revisit, or to see, or to hear what you missed. We are online, giving the online platform giving this better service. Teacher Alan.